السلام عليكم ورحمة الله وبركاته. أتمنى أنكم بصحة جيدة في هذه الظروف التي نمر بها. أكيد سليمون معافون من جميع الأمراض التي نسمع عنها. بالتأكيد سوف نبدأ مرة أخرى من أول درس كمراجعة سريعة، ثم نكمل دروسنا التي وصلنا إليها. نبدأ مع بعض. هيا بنا. Okay. Our lesson today is a revision in Unit 1, Force and Motion. You should know each word in science. Generally, in science, ask what is meant by. Each word you don't understand it, ask what is meant by. So, what is meant by force and motion? I'll tell you in a simplest definition. Okay, force. Force can be described as a push or pull on an object. So, this push or pull are trying to interaction on an object. For example, changing in speed, state, or direction of this object. And motion change in the position, just position of an object over time. Also, we can say it is a relation between position and time. I know it is a position over time, but also it is a relation, just a relation. Whatever. These definitions are for understand, not for sale. Okay. This is the answer. What is meant by force and motion, and this is the title of this unit. Unit 1 consists of two lessons. First one, types of levers, and second one, law of levers. On the other side, there are examples of levers in images. The biggest image, wheelbarrow, bottle opener, pliers, scissors, and pincers. Levers were first described in 2610 before Christ by a Greek scientist, Archimedes. He said, "Give me a lever with a rigid bar and a place to stand, I can equilibrate the world." Oh, I know. Some intelligent students will ask me, "Mister, you say lever, lever, lever. What is meant by lever?" It's a very important question. I know. To know what is meant by anything in our life, you should what is consist of, or what is made by, or if you want to eat it, what is the recipe. I know liver. We will never eat liver. The lever consists of rigid bar, whatever, straight or curved, rotates around fixed point, and affected by two forces, effort force and resistance force. Effort force try to equilibrate resistance force to set the lever, or to set the rigid bar in a balance. Okay, what is meant by also fixed point? Fixed point, it's a point where the bar rotates around, with a scientific term, fulcrum. The scientific term of fixed point, fulcrum. Okay. And effort force, force exerted by person to equilibrate the resistance. Now, effort force and resistance force. Resistance force, or load, the force that resulted from the weight of the body. The earth attracted any object to its center. Now, look at the left side in the bottom. The cowboy tried to equilibrate a big rock. In the right side, the man tried to equilibrate 1 ton. It's strange, I know. But remember, Archimedes say, "Give me a lever and a place to stand, I can equilibrate the world or the earth." It's very strange, but it's true. I know. You want lever to equilibrate anything. The importance of lever. Lever are very important in our life because they make the tasks be performed more easily by increasing force, increasing distance, increasing speed, moving the force from one place to another, accuracy in performance, avoid dangers. Now I'll explain each one. Increasing force. Some levers save the exerted effort by using a small force to move heavy loads. For example, a crowbar, not a cracker. Increasing distance. Some levers allow exerting force for a small distance to move an object for a large distance. For example, a manual broom. In the manual broom, your hand moves a small distance at the upper part of the broom, while its lower part moves a long distance. Increasing speed. Some levers increase the speed of objects that we inflict on. For example, hockey bat. Moving force from one place to another. In this example, also manual broom. The force of your hand moves from one place to another to collect the garbage without bending. Accuracy in performance. Some levers are used to pick up very small objects. For example, tweezers, forceps. And the last one, avoid dangers. Some levers are used to pick up the hot, cold, and poisonous materials. For example, coal holder and ice holder. Now with the second part of this lesson, types of levers. Levers are classified into three types according to the position of its components. Remember with me, the components of the lever are effort force, resistance force, and the last one, fulcrum. Don't forget fulcrum. Now, the types of levers are first class of levers, second class of levers, and third class of levers. We can say first, second, and third to remember them. First, second, third. It's very easy. To differentiate among them, identify the midpoint of the lever. The midpoint of first class of lever is fulcrum in the symbol O. We will use O as a symbol of fulcrum. The midpoint of second class lever is the resistance force. We will use R as a symbol of resistance force. The midpoint of third and last class lever is the effort force. We will use F as a symbol of effort force. Now, my intelligence students will ask me, "Oh, mister, how to determine the type of lever?" Step by step, mister, please. Okay, it's very easy. First step, determine the position of each component of lever: effort force, resistance force, and fulcrum. Second step, identify the midpoint of the lever. The midpoint identifies the type of lever. In this word, ORF. Again, ORF. O-R-F. O represent the first letter in ORF and represent first class of lever. ORF, the first letter in ORF, O, and represent first class of lever. Now we know if the fulcrum in the midpoint of lever, it's will be first class lever. R represent resistance. If R in the middle point of lever, resistance, or R, this lever will be second class lever. Okay, now understand me? The last one, if the effort force in the midpoint of lever, it will be the third class of lever. Remember with me, ORF. O represent fulcrum, R represent resistance force, F represent effort force. Don't forget ORF. It's very important because O represent fulcrum, if the fulcrum in midpoint, this represent this lever, first class lever. If R in the midpoint, this represent second class lever. If in the midpoint, this represent the third class. Okay, we will apply this in the next slides. Okay, keep attention and apply this one in each lever. Now let's learn more about first class lever. They are the levers that have the fulcrum O between the effort force F and resistance force R. Maybe fulcrum near to resistance force, as in case number 1, or near to effort force, as in case number 2. Whatever. The rule here, fulcrum between effort force and resistance. Okay, you understand me? This is an example of first class lever. This is nail clippers. Resistance force is your nail when you want to cut it. Observe that the fulcrum between effort force and resistance force. This is first class lever. This is the reason we bought it in the first class lever. Okay, this is another example of first class of lever. This is called pincers. Yes, pincers. Pincers, you can observe clearly the fulcrum or O in the midpoint of this tool. This is first class lever. Second class levers, they are levers that have the resistance force R between effort force F and fulcrum, and any lever has a resistance force in the middle called second class. Stapler is a good example of second class levers. Fulcrum, the point where the rigid bar rotates around. Effort force, when we push. Resistance, the force that resists effort force. We observe that the resistance force at the midpoint. The last type, third class levers. They are the levers that have the effort force between the resistance and fulcrum. For example, this is ice holder. Effort force in the midpoint, whatever, near to resistance, near to fulcrum, whatever, but at the end it is in the midpoint. Okay, thank you for listening and see you later in lesson 2.